Good morning. Welcome to one of the many rainbow tents here. I'm Andy Revkin. This is my 32nd year writing about science, which is kind of depressing in some ways, but wonderful in others because I always wake up excited about new frontiers. I've been writing a lot about climate change now through that whole stretch, and about ocean issues. I grew up wanting to be a marine biologist and then diverted into journalism because the PhD kind of felt like too much of a hurdle and too specific. You know, as a journalist, I get to see the whole picture from the North Pole to the White House to the Amazon. As a close focus researcher, I don't get that. Now, there's someone sitting next to me who has a much wider view of the planetary problems and opportunities than I ever will have, because she spent 3 missions on the Space Shuttle and has been immersed in the fields of geology and oceanography, and now is immersed in the arena of administration and governance. Remarkable. It's just a great pleasure to have a little brief conversation about what Kathryn Harrison calls environmental intelligence, and what NOAA, which is a very variegated agency, can offer the country in a time of climate change and rapid demographic change and complexity. The things we know about global warming profoundly are the basics. Greenhouse gases trap heat. Adding them to the atmosphere is changing the climate system in big ways. They're long-lasting because CO2 is a gas that once you release it, stays around for a long time. Has impacts on the oceans, many of which we're still just starting to understand in terms of the chemistry of the oceans. And you're sitting atop this infrastructure that's also aging in many ways. You know, NOAA and EPA and NASA, we all got going in a big way in the 60s and 70s, and now how do you maintain interest in understanding the world in a way that how do you maintain the investments as well? So I'd like to start with this, just to remind people of your own trajectory. I mean, what led you to be in this position, very briefly, you know, and how informed are you by your space view of the world?
Well, the long and winding road for me is a little bit the opposite of yours. My first fascination as a very young child was maps and sort of every facet of geography of the planet. Who lives places, what are the cultures, what is the landscape, how does it all work? And I first thought I would go into languages and linguistics. I have a certain talent in that regard, and I would turn that somehow into airplane tickets and the ability to really travel and understand the world. I discovered the earth sciences as an undergraduate and saw actually the wide field through the eyes of the research professors that I was working with. They knew the whole planet, they knew places, they'd lived there, they studied, you know, thoroughly what was going on there. So that's where I shifted gears into wanting to be a scientist who understood the planet. NASA happened to open the doors for women and scientists to go aboard spaceships with the dawn of the shuttle program in the late 70s, and that lined up very well with my PhD completion, and so I went straight from graduate school into the space program. You know, that is an experience on 2 counts that will stay with you, I think, and help inform and shape, I think, everything I will ever do. One count, of course, is the multifaceted complexity of putting a mission together, putting a complex, multi-party, multi-purpose, both highly technological and very high human performance endeavor together, involving so many people and so many different organizations and cultures. And then the other, of course, is that extraordinary opportunity to look out a spacecraft window and see the Earth from that vantage point. The shuttle can only go to about the altitude where we currently have a space station. It's not like the Apollo guys. We never saw the Earth as a grapefruit off in the horizon or a small dot that we could blot out with our thumb. Yeah. It was more of a basketball-sized object, but it was, you know, it's definitely a ball. It's a single thing.
And you can see the veneer of the atmosphere from up there in ways that we don't appreciate.
And veneer is the right word.
Yeah.
I mean, you know, literary metaphors for the atmosphere are often suggest great scale, the ocean of air. But it's more like the fuzz on the tennis ball than it is some vast ocean of air. It's a membrane that envelops the Earth. And you go around the entire planet in an hour and a half. You know, every time zone in an hour and a half. 16 sunrises and 16 sunsets in a 24-hour period. It really radically changes your sense of the scale of this place that we live. And then finally, you see both huge, massive systems, you know, the great flow of the Gulf Stream or a hurricane, and at the same time, the finest filigree detail, like little tendrils of dust going across the Atlantic from an African dust storm. So there's both this extraordinary scale and massive power, but the Earth itself reminds you at the same time that with that power there is an elegant interweaving of phenomena and of dynamics that are just barely discernible with the naked eye. And as a scientist, you come to know they're really the indispensable elements of how the planet actually functions and works as a system of systems.
So now that you're in this agency, running this agency that has, again, all these tendrils and operations, what's your vision for how to help society grapple with things like what happened in Texas with the extreme flooding and what we know about sea level, which is more complicated than people used to think. And there's not one sea level rise, even though there's really just one global ocean. So what are the issues, what are the opportunities to help society navigate this, the Anthropocene, as we've been calling it?
Yeah. Well, I mean, NOAA is a very multifaceted agency. We are fond of saying that our mission extends from the surface of the sun to the bottom of the sea. That's not an exaggeration. We're the Space Weather Prediction Organization. We've got a spacecraft that sits 1 million miles away from Earth on a direct line to the sun and serves as the weather buoy when the sun sends out these big coronal mass ejections like it's been doing all this last week, pushing the aurora far, far, far south. That satellite sits there 1 million miles away and confirms that the blast is headed right towards us. And we can make that prediction, which is good for aurora watchers, but it's really critical for satellite operators. These blasts can knock out satellites. It's awfully critical for pipeline operators and major transmission system operators because the electric field can induce, the magnetic field embedded in the burst can induce electric currents in long conductors and blow transformers. So it's got a lot of consequences to the built society that we have. So from space weather to everyday weather to the longer term phenomena like El Nino, monitoring them constantly, taking their pulse and developing the ability to predict their future state so we can factor that into our weather forecasts. We're the United States Fisheries Management Organization for ocean fisheries, and so also the United States touch point and lead in the global fisheries management organizations worldwide. We're responsible for the country's national marine sanctuaries and stewardship of ocean protected areas, and also are the advocate and negotiator oftentimes multilaterally, again, around the world to try to encourage ocean conservation broadly. So fisheries, coastal zones, most of the population and increasing share in the United States is concentrating in our coastal zones. The same trend is occurring globally. So we have an increasing numbers of population and increasing amounts of infrastructure exposed to the full strength of coastal storms. And again, those forecasts, those predictions during real-time events. But looping back to what you were getting at, people build and live and run businesses in those areas. And another facet where NOAA plays in is that it's very often NOAA data on the state, on the sea level, on the tide, the current, the weather, the climatic trends, that companies and communities are factoring into their plans as they try to figure out what changes are coming ahead for me in my community. What's the trend I need to be thinking about as I try to build Norfolk forward for the future or Denver for the future. This is what I've been calling environmental intelligence, that actionable, reliable information that's actually attuned towards decisions and questions that are real for businesses and communities and people. And it's a lot of times it's NOAA's work and NOAA's effort that does the science, but then gets the science off the page of the journal into that forecast or that outlook or that information product or that planning tool that a mayor is using. Mitch Landry, who's here from New Orleans, for example, they're participating in the 100 Resilient Cities program, and a huge amount of the data that they're relying on to understand how to factor the changing environment of the southern Louisiana coast into a viable future for New Orleans. A huge proportion of those data come from NOAA.
When you must have, I can't imagine what your morning wake-up to-do list looks like, given all those dimensions you're talking about. But and I'd like to focus kind of on the longer-term goals as opposed to the day-to-day stuff. But when you look at that matrix, and I assume it is a matrix, what are your biggest headaches? What keeps you up late at night or wakes up early in the morning is something that isn't happening, whether it's related to funding priorities or whether it's related to aging infrastructure? What are the things that worry you, given this intersection of societal pushes into danger zones and climate change and all that? What are we missing?
One thing we're missing is how critical it really is that we continue to keep taking the pulse of the planet. We're still living off of a real slug of investments made basically in the 80s and 90s in both NASA and NOAA and the National Science Foundation that changed the nature and scale of the instrumentation that we have to monitor the planet, to measure the moisture and temperature in the atmosphere. That tells you the energy of the atmosphere, and that's what you use to predict the weather, make the weather forecast. To monitor the state of the ocean, the physics, the chemistry, most of all the biology. The ocean's much, much less sampled than the atmosphere. And we're the first generations of human to ever be able to understand the Earth this way, to see it from space as a whole, to use satellites to give us essentially snapshots of the atmosphere, snapshots of the ocean. And that is a big part of what has revolutionized our ability to provide forecasts and outlooks that give us some foresight about the conditions that we need to be preparing for and anticipating. Yeah. But sustaining that kind of observing infrastructure, the irony is just as the uptake of this information into societal decisions is growing rapidly, the observation infrastructure is aging, and the vision and the understanding of the importance of sustaining it is difficult to muster. So that's what keeps me up, I think, most at night, is that the demand and need for the kind of information and understanding that NOAA can provide for folks to use in their everyday life and world is just soaring, and our capacity to produce it and the observations that are critical to producing it don't have that same kind of energy behind them.
One thing I heard recently, an exchange I had by email with Bill Gale, who used to be the head of the American Meteorological Society. He was frustrated with some of the rhetoric in Congress about wasting money, that NOAA is spending too much money on climate research. And the point he was making was, if you don't think it's global warming and you think it's everything that's happening around the world is a function of uncertain dynamics in nature, it's even more important to invest in science. So he was basically saying, whatever your ideological position on global warming, maintaining or boosting this infrastructure should be a vital priority, it's not a reason to relax uncertainty or complexity.
Oh, that's absolutely true. And I mean, let's put the political definitions aside. Weather is phenomena that happen on a daily to about a 14-day basis. Storms, heat, cold, whatever. That's weather. Climate is simply the statistics of those things on longer timescales. The ability that we have scientifically to produce a weather forecast from day 5 to day 12, there's actually now meaningful skill in day 12 forecasts in most cases. That comes from understanding these longer term signals like El Nino and factoring them into the forecast process, because they actually sort of damp out and temper the errors, the chaos that would otherwise overwhelm the system. It's a really dynamic, turbulent system that we're trying to predict. So put causation, put carbon regulation, put all of those factors aside. The data, the measured data of our planet are making very clear the planet is getting warmer. That's shifting the statistics of intense weather events, more of them, more intense, and different geographic distributions than we're used to. The so what to that is, we built our agricultural enterprises on certain presumptions of these climate patterns. We built our built infrastructure on certain presumptions of our climate patterns. If you're staying at the Meadows, read the little sign inside your room, the door of your hotel room. It says there's no air conditioning here because this is the climate of Aspen. And we don't need it, and we know that. It's been this way forever. But if those patterns are shifting, we're in for a lot of change that will impact our businesses, our infrastructure, our livelihoods. And warmth plus humidity impact fundamental human productivity because of the physiological effect. So the data are pretty clear. We are in a changing world. The past is no longer a good predictor of the future, and that just puts a tremendous premium on being able to keep the pulse of the planet.
And can you, one thing we were talking about earlier today was there's this mid-range between the 2-week weather forecast and the century-scale climate forecast. What's tractable there? What investments do we know can sort of start to clarify some of that mid-range space?
Yeah, that right now is sort of the biggest science gap. And scientifically, the challenge of forecasting the weather is a fundamentally different problem than predicting the climate. Forecasting the weather is measure the condition, the state of the globe, in particular, the temperature and moisture in the atmosphere at thousands of places, essentially simultaneously. And then using the equations of motion and our understanding of Earth processes embedded in computer models, propagate that forward. So it's an initial values problem. What was the starting state? Propagate that forward. The climate prediction is more a boundary values problem. There's a certain quantity of heat and a certain dynamic in the rotation of the Earth and a certain amount of solar energy coming in. What's the range of possible conditions that can take 50 years or 100 years down the road? A whole lot of the decisions that should most take a changing Earth into account sit in the 1 to 3 to maybe 10-year time frame.
Right.
And right now, scientifically, we've not solved the problem of how to connect those. How much further out can you take weather prediction, more deterministic prediction methodologies, and how do you scale down and bring into the couple of year time frame at a smaller geographic
Right.
scale the boundary values. Many people are working on it. NOAA's got a big push on that that's going to initially focus on trying to move severe heat and intense precipitation forecasts out to the 1 month scale. Again, not a randomly chosen time frame. As we talk to emergency managers and civic planners, we try to find out what's the question you're most struggling with, what's the public benefit need that would be most helpful to you if we could push the science to get there, and that's what we will focus on, and this is a sweet spot in that domain.
Although this is an arena where I've seen what could be a potentially problematic disconnect between public expectations about what science might be able to offer the mayor of Chicago or countries in sub-Saharan Africa for the coming decades, and what some of the fundamental limits of climate
Yes.
simulation are real and profound. Gavin Schmidt, who runs NASA's Goddard Institute for Space Studies, years ago, I've interviewed him thousands of times, well, hundreds, and he said there are some aspects of this that don't expect that we'll be able to solve that for you. And I wonder if you worry sometimes about that public expectations might get too inflated. Hey, we really want to know what our planting cycles are going to have to be. And then, just the last year with the El Nino forecast, the media picked up on the idea there might be a big El Nino last year, and then that bubble went away, and now there is an El Nino this year, although we don't know how long it will last and stuff like that. Do you get any sense that that's a concern? That more science doesn't always make things clearer. There are aspects of global warming, even hurricanes. When I first wrote about hurricanes in a warming world in 1988, it was simply a matter of warming oceans make these storms happy. They thrive on warm oceans. But then it became clearer through more research that hurricanes are complicated beasts, that the atmospheric dynamics can kill hurricanes just as much as make them thrive. So is there a problem with science? Do we have to sort of say sometimes that science won't be able to answer some of these questions?
Look, it's a mixed bag of problems. One is, what kind of answer are you expecting? And if you're
Right.
expecting, I would like to know 25 years from now in my garden at the base of Red Mountain in Aspen what my planting cycle will be. The likelihood of being able to give you a 5-10 year forecast for that specific to your garden, that's low. That's an expectation of scale of prediction or precision of prediction that you're not likely to make on those long time frames. This kind of boils down to what sort of information can fit into what decision frameworks.
Right.
And so what you may well be able to do is to say, at the scale of the Roaring Fork Valley, 5 years down the road, 2 years, 10 years down the road, that your likely planting zone is going to be in this range instead of that range. Now, we factor longer term trends into our planning as individuals and businesses all the time.
Right.
And it's not because someone precisely can tell you, the price of your key commodity in your supply chain is going to be 32.4 at this time.
Right.
It's, the curve is rising into the future. You have to anticipate tightened supply or higher prices or lower demand. Those are risk-based decisions, and you make hedging decisions. You decide whether to prepare for that in advance or begin to shift into some other direction so that you've got a viable living proposition going forward. So we're going to have to learn our way into this. I said earlier we're the first generation to have this ability to understand the Earth in the way that we do and to be able to transform that into prediction, into meaningful, practical prediction. Human beings crave some knowledge of the future. I mean, it's really pretty miraculous capability to have about a place as complex as our Earth.
Yeah.
And we're even more babies than that in terms of understanding how to factor it into decisions. Where can we make use of it? How precise can it be? And if it's not as perfectly precise as I want, can I understand it enough to take some account of it, or am I just going to dismiss it? I do find it interesting and sometimes instructive to turn it around and have the same conversation with myself around medical research and medical certainty, because we deal with these same sort of scientific factors in the world of medicine all the time. And if you had seen 100 doctors and 97 of them gave you very tightly the same diagnosis and the same prognosis, you would not be banishing the word cancer because 3 guys said, I'm not sure that's what it is.
Right.
Or they said, I don't think I understand your cancer exactly. So we do know how to do these things and take account of these kind of factors. It is a challenge for human nature on abstract, distant in the future challenges, but I think we're going to have to grapple with it. And it is beginning to happen. I mean, you are seeing this in communities at the grassroots level, all across the country.
There are innumerable instances I've written about over the years of where the vulnerabilities are clear, the science is crystalline. By the way, this doesn't just relate to climate risk, earthquake hazard,
Yes.
and where communities aren't adequately
Tsunami
responding
hazard,
to the science that's there. I know as a journalist, I grew up, I've been spending 30 years trying to convey problems using data to the public, and then you see these fundamental disconnects between what we do and what we know. And that's this paradox. I'm sure as a scientist you've felt this, why don't they ... And this Texas was a really good example of this, where the Flash Flood Alley, that area west of Austin that I wrote about a month or so ago, the history of these extreme flood events there is just clear cut.
Yeah.
The development pressure though is boom, 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 build, 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 and what do you know? We have a huge problem. Katrina, New Orleans was a sitting duck for even a modest, it wasn't even a major hurricane when it came through.
Wildfires, development at the wildland boundaries.
So this gets to the question of like education and or, so how do you see opportunities to make the knowledge that NOAA has gleaned somehow more impactful in that way, that actually integrates with flood insurance costs, or where a zoning discussion and West Texas kind of actually takes this into account? What are there any opportunities for us? And I mean journalists, educators, getting data out there in ways that are novel and visual. What can we do?
Well, that is a side worth working on. How are you presenting that? How is the data reaching people? In what kind of form? And we are working more in that domain than ever before at NOAA, because we see it on tornado warnings, short-term things that are bearing right down on you, as well as these episodic things like flash floods or wildfires. And we care a lot and work hard to try to make sure that we're doing everything we can from our side to put the information out in the way and in the channel with the colors or the language or the whatever that accelerates its movement to action, to timely and appropriate action. So we used to do teletype tornado warnings that were this long, and the punchline was on the last line in very scientific-y words, and our guys would be a little astounded that no one read beyond the first line and they'd missed the punchline. And we've turned that paradigm around completely with very vivid kitchen table human language right up front, talking about the impact this is going to have on you as opposed to the character of the tornado itself. And we are finding that makes a difference. On the longer time scale stuff, one of the big thrusts we were working on at NOAA is under the banner of resilience, providing the information and services that can help communities to become more resilient. I think the information and how it's delivered will be a piece of that, but another dimension we're engaging in, we're not really leading it, is to try to understand how can this information, how can these clear scientific points get better attached to economic decision making? How can those forward risks, however well determined and however well characterized they can be, are there ways that they can be taken up into normal, routine, everyday decision making? So we've been doing a lot of work with the primary and secondary insurance industries, better understanding how they're doing catastrophe modeling, what parameters from the environment are they factoring in, Is there data that we have that we didn't realize is pertinent and helpful to that point that we can get out to them and help improve their ability to sharpen the focus on risk? Are there other ways to bring risk factors into play and get pricing signals attached to them?
Yeah.
The Sustainability Accounting Standards Board, some of the community resilience work that Bloomberg and others are funding, the work that Bloomberg and Coca-Cola and World Resources have done around water risk, which became a water scarcity and risk tool, and again, a map-based information product that is now incorporated in the Bloomberg trading terminals. So as everyday economic decisions are made by traders and Bloomberg customers, they've got the ability to look geographically and by sector and by different kinds of industry to future projections into what kind of water supply likelihood or risk am I facing if I invest in a company that wants to site a plant here and is counting on long-term returns, but against that water backdrop with that product line. So bringing this kind of insight into those sorts of decision platforms is one of the ways that I think will change the equation over time.
Great. Now I want to make sure people are ready to start thinking about your own questions, because your opportunity is coming in a moment. Can you talk about the National Water Center as kind of an example of a sort of an integrative approach to looking at risk?
Yeah, water is a tremendous challenge, and getting your hands around it scientifically and from a management point of view is almost an even greater challenge than that. The data are very disaggregated. Some of the data you would like to have are properly private data, some are state held. Some is federal data, like the Geological Survey stream gauges, data from some NASA satellites and NOAA's NexRad radar networks, which are basically volumetric rain gauges. So some is out in the open, some is just esoteric and hard to find. There are tens of thousands of wells in this country alone that are unregistered, unrecorded, unmonitored. So whatever the water withdrawal from those wells is, one doesn't know. And so when you try to, again, model this so that you can begin to get some understanding of the inventory and of trends of demand against the inventory, it's really a challenge to bring this all together. So there was just established on the campus of the University of Alabama about a month ago, a new entity called the National Water Center. NOAA hosts the building, but the U.S. Geological Survey, the Army Corps of Engineers, one of the big water management federal agencies, FEMA, are all going to be co-located there with the cooperative academic community that does hydrological forecasting. And the idea is to try to pull these strands together and move forward to where we can get to integrated water modeling that will let you, look through the focus point of water at either energy or food or basic human needs, or at the nexus and the interdynamics that exist between them. Because right now you have power plant guys modeling their energy need with sort of no regard for the natural environment and the implications there, or for what those withdrawals might do for an adjacent municipal area. And the municipal manager will sort of do the same, and the agricultural interest will do the same. But we're all tugging on the same drop of water. And as water scarcity intensifies, and it is across the entire country, not just in California, 35 states in this country are currently involved in disputes with their neighboring states over water, 35 out of 50. The most vivid headlines are the California drought, but that's far from the only place where we're beginning to see this water, energy, food nexus really tighten up and become much more challenging to deal with. So what we're aiming to do at the Water Center is accelerate the science, and again, this is science oriented towards practical decisions. Some of it will be very fundamental, deep research into how things work, but the motivating force will be to try to bring better tools and better insights to all of us that are struggling with these water issues.
Great. So are there questions? Oh boy, I had a feeling.
All right.
You could duke it out. No, just kidding. The woman way over there, and then the man here in the plaid shirt, and then the guy way in the back, and then we'll just try to.
Okay.
No, I won't forget you. I'm looking right at you. I wanted to start with the area I wasn't looking at. So.
Hi. So I want to start
Could you say who you are?
Yeah, I'm Kara Leckie. I'm actually a physicist at NASA, and I have some experience working with NASA legislative affairs. So
Can you hold the mic a little closer to your mouth?
Okay.
Yeah.
That is better. So.
Pretend you're a rock star.
Okay. So working a little bit with NASA legislative affairs, I've seen firsthand some of how NASA tries to educate our policymakers about scientific issues. And my question to actually both of you is, how do you think NASA and NOAA can better connect with the media and leverage the media to result in, I'll use the word pressures, but there are districts where there are representatives that are trying to, for example, cut the earth science budget in NASA currently by a huge amount. I don't know the status of that, but it's being discussed, I guess. So how do you think that NASA, I know we have restrictions on, we can't lobby, for example. What are your thoughts on that?
So as both a NASA alum and a NOAA alum, NASA actually has vastly more capability to do this than any other federal agency because of the leverage or the latitude given them in the Space Act of 1958. One explicit part of NASA's mission is impress the American public and make them proud of what you're doing. So they have an education and outreach budget, which is often and substantially used for what anyone else would call PR, that we joke is the size of a small agency. I should add the current head of NASA is a fellow astronaut who I flew with twice and adore, so this is all in the good colleague joking around stuff.
You're jealous, in other words.
Yeah, oh, absolutely. I covet that budget. They do vastly more media. They have their own television channel, for crying out loud. They do vastly more media and splashier social media and so forth than really any other agency has the capability to do. So the media play can serve a role there. What we tend to focus on in NOAA more than that is the legwork of making the case directly to legislators and their staff. And because we're so much more coupled to the applications world. I always view NOAA as sitting where the knot in a bow tie sits. And there's this whole world of information needs. There's sort of the clinical needs equivalent in the earth science arena. And we work to really know what those are and then go do or harvest the science from anywhere we can find it and transform that into something that will actually meet those clinical needs. And so we work on helping make sure that those users, the Weather Channel, AccuWeather, it is not true that if you defunded my agency, you would be fine because you have the Weather Channel, because the 2 terabytes of data that we publish every day are what make their business possible. So those folks, what we're finding is the real people in the real world running major multi-billion-dollar companies, running communities, running small farms, who know they need these data. They are the ones who validate the need, and their voices are very powerful back to the Congress.
Just very, very briefly, I was in the media, the conventional media, for 30 years. I still write for the Times, but I teach at Pace University in a communication division, not just journalism, because as I say often, the traditional media are a shrinking wedge of this explosively growing pie of ways to share and shape ideas and information. So there are great opportunities, pretty cost-effective ones, for agencies to work directly with the public through Facebook and these other portals to not just tell their story and justify their existence, but get that data out in meaningful ways. And maybe partnering
Social
with...
media is a huge player in actually weather forecasting and getting people to act on the weather. Both inbound information that our forecasters use and outbound information, and then lateral confirmation across a community that often spurs the action.
Yeah, so who had the
Plaid
second?
shirt.
Yeah, I said plaid shirt and the guy in the back.
Thanks. My name is Jim Chafin. I'm a real estate developer of human settlements with a environmental focus and ethic. And I'm constantly amazed at the number of friends that are who know of my passion for balancing economic viability and environmental sensitivity and community livability. I'm constantly amazed at how otherwise intelligent and enlightened people say, Chafe, you're just too radical about this. There is no proof. What proof do you have that we are impacting the environment this way? So I would love to have your 4 or 5 sound bites or elevator talk on, consider these 5 points of how we are impacting the atmosphere and therefore the future of our planet.
If we can
I've had that conversation too, and 4 or 5 or 40 or 50 points don't always change those viewpoints. Look, the basic physics of how and why adding fossil fuel emissions or carbon to the atmosphere would make a difference goes back to 1896. This is not new hocus pocus, fad-ish kind of science. A NOAA researcher starting in 1960 trudged up to the top of Mauna Loa every day, once a month, for years. Just grab a bunch of atmosphere and measure how much CO2 is in it. And that's that famous sawtooth curve that begins to rise and accelerate in the 70s, called the Keeling curve. His son continued it after him. So any notion of what's happening on this Earth that doesn't take account of that measured amount of carbon in the atmosphere that the Keeling curve demonstrates is going to fail. You have to take account of that. And the very best understanding we have, the very best measurements we have, and the very best embodiment of that understanding in computation, the very best, cannot account for the conditions we're seeing on the planet now just by all the sources we know of natural variability, including the 11-year oscillation cycle, including solar variability, including all the things we know of at the magnitudes we know them. Put them all in, run it. You will fail to be able to account for the patterns that we're seeing. You have to begin to drizzle in extra carbon added by human use of fossil fuels. It's the only way you fit the curve. And again, in every other field of science, from your medical doctor to anything else, how do you fit the evidence? Give me an explanation that fits the evidence. And the measured evidence requires you to include the human contribution.
And one thing that I've found over and over again is in zones of environmental hazard, whether it's a coastal area, floodplain, an inland floodplain, the Colorado red zone, fire zone, if you as a developer can demonstrate, with or without climate change, that you're building structures and developing landscapes in ways that account for these real hazards that are there. The fire vulnerability in Colorado that's been built by development patterns swamps what we know climate change has added to the picture so far. So it's irresponsible. If you can make the case that responsible development of land takes into account fundamental hazards, building a house that isn't going to burn down because you're shaping the landscape around it using native, we can go into a long conversation on it. There's huge opportunities that get around the ideological battle over climate change. Headwaters economics, just Google for that. They're a free market economic consulting analysis place, and they did a whole thing on building in fire zones that shows you all the hidden subsidies that we all as taxpayers are paying people to build in fundamental zone of hazard with or without global warming. So you don't have to go, you don't have to even go there if you focus on vulnerability reduction. And then it becomes your play, you are the smart player. You don't have to deal with that.
You also don't have to go to human causation to show that the statistics of severe events are changing.
Right.
You don't have to invoke the causation. The statistics are changing. So
right.
If you're going to build in a coastal zone or if you're going to build at the wildland boundary, your probability of occurrence of a fire that could really be damaging or a storm that could damage your home, that is going up.
Yeah.
Or water levels,
Sure.
storm plus surge, that's clearly going up. You don't have to, if you don't want to, don't have the whodunit argument. You're facing a rising curve of risk, and you can offer designs that mitigate against that.
So we have 20 minutes left, which is good. I had promised him the next question. Who had I promised a question that I hadn't?
These guys don't want to be forgotten either.
Yeah, I know. So you and then Jane.
Yes,
and
good
then
morning.
We'll go back here.
My name is Jorge Benitez, and I'm a retired technology executive. Given the predictive analytics and big data and all of the advances that we see in tech, how close are we? Are we in a matter of years or several years or decades to be able to have the predictive part of weather be much more commonplace, in particular as it relates to tornadoes or hurricanes that may strike the coastal zone, but exactly where they're going to turn, and those kinds of things that could really save lives? I mean, how close are we?
I would actually argue we're in an awfully good place now. I mean, 10 years ago, a hurricane prediction would have gone out only 3 days, and the uncertainty cone would have been like this at the 3-day point. They now go out 5 days with an uncertainty cone like that. So the track forecast improvement has been substantial and continuous over the last 10 or 12 years. And we're just beginning to crack the nut on intensity forecasting, which is just a tougher scientific problem. And we're getting much better at coupling the ocean in terms of surge that will come in with the storm, so that you can get a total inundation model, which is, it's not wind that kills in a hurricane, it's water that kills in a hurricane. So the state of the art of that is actually very impressive for short-term weather phenomena. I would say the same in tornadoes. I won't go through a big explanation. But on the big data front, one of the things to remember is, as dynamic as this planet is, weather forecasting and climate prediction will never be purely data mining. You've got all the data you need, just recalculate it or redo the statistics. Current observations at multiple phenomena and timescales are going to remain needed. Having said that, NOAA collects about 20 terabytes of data a day. And as an artifact of leftover architectures, we only get about 2 terabytes of that readily out the door for the public to use. We've just cut 5 commercial R&D agreements, these sort of open-ended exploratory contracts with Google, with IBM, with Amazon Web Services, with the Open Cloud Consortium, and I'm just brain dead, Microsoft, that boil down to, will you guys step in and take the step to throw the 20 terabytes up into the cloud so that entrepreneurs, app developers, other scientists can more readily work through that, and if there's got to be some hidden treasure in there that's applicable to either furthering some understanding scientifically or improving or developing a new information product, and we just want to expose this all and let the market and let innovation take it forward.
Yeah, and I'll just add that there's huge opportunities in the social sciences,
Yes.
because it's going to take a long time to improve the climate models and get more predictive capacity into these models. You could right now change responsiveness to tornado alerts, to figuring out ways to have communities do better planning so that in Oklahoma, it's not the norm still to have houses with no basements and no safe rooms. Some of these zones of hazard, the opportunities, the untapped opportunities to change preparation are there and can be changed radically in the space of years, even as we work at the science for decades. At Ready.gov over at FEMA, people are working on ways to get at that, and it's another great opportunity. So social science is really important.
It isn't always about improving the science. I mean, tornado warning lead times gone from about 4 minutes when I was with NOAA in the 90s to an average of about 14 minutes now. Some folks in Congress are pushing us to just set a target of make them be an hour. Well, we've sort of seen that experiment in Oklahoma City last year where media jumped ahead and an hour before very well predicted tornadoes came in, we put it out on the television. The response was not people making better effort to quickly get to safety. The response was people got on the freeway to try to go get their kid or meet up with their husband or get to the other side of town. You ended up with more people in harm's way with the longer lead time because the instinct that kicked in was not a safety instinct. It was a, I have enough time to get a few things done instinct. So it's a complex social science problem.
So over here.
My name is David Miller. I want to build upon the question over here. We're talking more on a micro level of facts and movement. Can you, and it's a question for both of you, how does the scientific community get the message out macroly of what's happening in a unified way? In his question, people will refute it, and we have scientists on either side of the equation of yes, there is climate change, or no, there isn't, and how does the community galvanize themselves and help with a unified message politically and in layman's terms so people get the longer term future and not just how we're using it for the next 2 weeks?
Tough one.
Yeah, that is a really tough challenge. For starters, let's be clear, the statement scientists are on either side of the issue, but let's be clear, there's 97, 98 scientists on this side and there's 1 or 2 on this side. This is not like seriously a debate with comparable bodies of evidence. But having said that, the primary tool that's used in the science community and at the science and policy interface is something we call assessment, not the greatest word, but the IPCC, the Intergovernmental Panel on Climate Change, and in the United States, the National Climate Assessment, are exercises in which hundreds of scientists come together and take stock of all of the available research, all of the peer-reviewed research, and try to synthesize that to say the best guidance that these hundreds or thousands of studies can provide the best guidance about likely trajectories for CO2, about likely trajectories of temperature or of humidity. The best guidance about likely geographic distributions is X. The best guidance about likely consequences or implications for certain geographic regions or certain economic sectors is Y. So those are done every 4 years, and they paint that backdrop of what is the best evidence and understanding science can provide of what that longer term future may be. Again, it is not scientifically possible to put a point forecast out and say the temperature or the rainfall will be X at this point in time. You get ranges, but ranges of possible outcomes are not foreign experiences to human beings, and certainly not to humans who are engaged in business. There's a range of possible outcomes on that business case. That's why you analyze several scenarios as you set your path forward. That's why you hedge certain aspects of the course that you're taking. We all do that all the time. That's the mechanism that the science community uses to serve up a coherent understanding of what the science to date has provided.
So just very briefly on that, I made a big mistake professionally in how I covered climate change. I spent the first 25 years writing about it as sort of a geophysical question. Gases come up, warm the planet, things change. And then it was like from mid-2000s on, the mid-aughts on, whatever that is, I started focusing on the behavioral science and sociological work. And that's where I realized that you'll never get a unified societal view of the science. Dan Kahane at Yale has done he's a psychological researcher, has done empirical work that shows that some of the most literate people examining the climate question are those at the edges of the question. The most skeptical people have the most basic knowledge of what's a greenhouse gas. But their science is the way they view the science is shaped by their perceptions and their ideological background, cultural cognition, he calls it. So when you see that, you can kind of say, oh crap, I guess we're done. But then when I dug in more on the behavioral work, you start to see, as I said earlier, libertarians and environmentally conscious liberals know that building in a floodplain is a bad idea, and we don't want to subsidize that. So you can have a discussion about resilience that that gets around those bigger ideological, profound questions that aren't going to be answered by a new IPCC report. I did a piece recently, there's no red and blue states when you talk about investing in energy, renewable energy frontiers, and when you talk about even regulating carbon dioxide, the red-blue thing goes away when you look at it state-by-state basis. So there's lots of opportunities to have smart approaches to aspects of the problem that come from the social science we were talking about a minute ago. Jane, you had a question, and then where was he? Someone I just had acknowledged. The guy with the baseball cap there, and then way over there.
Jane Lubchenco, Oregon State University, and the first U.S. Science Envoy for the Ocean. Kathy, you've been a real champion for focusing on environmental intelligence and how important it is to have that to inform our understanding and enable really smart decisions. You also talked about the challenges inherent in keeping up the infrastructure to maintain what we have now, much less expand it into areas where we don't have as much as we would like, for example, in the ocean. And given many of the changes in ocean circulation, other changes that are underway, that actually has very real ramifications for all of us, for our weather, for lots of other things. So my question is, what's your vision for the future of Earth observing using some of the new technologies, microsatellites, wave gliders, as a way of adding to what we have, expanding in some new arenas, but also addressing some of the financial challenges?
Yeah, I think there are a lot of exciting new prospects in transforming Earth observations. I fret about whether they will materialize quickly enough and get into wide enough use. But yeah, there are now autonomous vehicles both for the ocean and the atmosphere that are of a radically different, smaller scale economically, financially. Can they, proving we can really use them to do some of the kinds of measurements we've historically needed is going to be an interesting challenge. There's also, we built a system starting in the 80s, let's say, that goes about these measurements in a certain way. And one of the real interesting challenges is to look at all the things we're measuring with 25 years of experience and see if we can back up a little bit and say, it turns out of these 50 parameters that gave us the deep science understanding, it's 3 we really need to monitor for a long time. Your doctor doesn't measure 700 things every time you go in for a physical. There's sort of the 5 vital signs right up front, sets the game. Can we get back to where we maybe can focus on a smaller number of vital signs and have the kind of information that we need? The other thing that's going to be fascinating, and it will have technological and commercial and policy challenges just threaded through it, is as technology diffuses and as the value of environmental information becomes more apparent, you're seeing already, and you will see more, private sector, commercial entities coming into the arena and saying, you know, I can finance a satellite or a set of sensors that'll produce some information that I can then turn into valuable business intelligence for someone, and I'll finance that myself. And among the policy questions will be, at the bottom line, would it matter, would it not matter, good, bad, or otherwise, if everything about weather forecasting in the United States were completely privatized? The model we've long worked on globally is every country makes its measurements and every country shares with the others at no cost, because every government has a fundamental responsibility to protect its citizens, and no one can do a weather forecast without data from the entire globe. It's a 125, 140-year agreement among countries. Was that a good 140 years and now a new model, or should all this new commercial activity be additive? We're going to live through that in the next 5 years or so. Oh, I haven't done that work yet. Don't know.
Well, one thing, a vulnerability index, I think, is a really important thing, and the agencies and other groups are doing that. Identifying spots of vulnerability is the key thing.
Which we do a lot in
the guy with the hat,
in particular.
then you. Let's do it like a lightning round of questions. Let's do 2 or 3 questions right now because we're getting down there. So state your question briefly, then here, and then
Sherry.
And then here in the front.
Kevin Yorman from
then
Los
Williams.
Angeles, California. I'm a high school teacher and here on the Bezos Scholarship. My question for you is, have you ever thought of, and has our government ever thought of, the feasibility of building a national water pipeline to go from flood zones to the drought zones, where when the floods occur, you open the floodgates and the water goes to where it's needed? It seems like it would be catastrophe management, and we would save billions of dollars, save thousands of lives, and we wouldn't have a lot of the problems our country is suffering from right now.
Okay.
Interesting question. So then the gentleman here, and then right here in the front.
David Mosina from the Museum of Science and Industry in Chicago. Kathy, thank you for your great long public service. Does NOAA measure public awareness of this? And if so, or if not so, what's your opinion about the state of public awareness, the general public?
Of climate vulnerability or
Of climate change, vulnerability, with or without the cause?
Right. And then here in the front.
I'm Sherry Turkle. I'm a social scientist, and I've been studying what I would call objects not to think with, objects that people don't want to think with, problems that people don't want to think about. And I would say that climate change falls into that category because you can talk about it all you want, but then all of a sudden it's a beautiful sunny day, the most beautiful you've ever had, and somehow all the issues about warming or not warming seem to go away. And that's, of course, the kind of research you're pointing to. But I was very struck in your presentation by the part when you said, I looked back on Earth and the atmosphere was just fuzz on a tennis ball. It was barely a membrane. In other words, there was an emotional experience that you had that made the notion of our vulnerability and fragility so real to you that there was no going backwards. And I would just wonder if you could speculate that that's the kind of experience that no matter how many floods, no matter how many hails and droughts we have, we don't seem to have come to yet. If you could just speculate what that would be that could give us that kind of feeling.
So it's very very related to Chicago Museum question. So, and then we'll go
so to your input, sir, there have been various efforts and plans and proposals around that done at regional scale. I'd recommend Robert Glennon's book Unquenchable if you want to give it a read. And it seems to always look good and sound good at the beginning, and when you actually go look at what's the mileage and what's the pipage and how much electricity and fuel are going to need to pump it up and down all the different elevation changes, you kind of quickly come back around and say, if you bought everybody, If you bought and gave away to everyone in Southern California low-flow shower heads and low-flow toilets, you would knock the scale of the problem down so far that you wouldn't even be thinking about those kind of issues. One-time expense, and now you've got systemic demand reduction. Australia and how they've handled their 13-year drought is very instructive in that regard. David, NOAA doesn't do broadly general public awareness research. We track closely work done at Yale and Columbia and other academic areas, and now and then as the Science Museum community does public service research, and we check in on that as well. Our only stats are through climate.gov and the user networks that we see touching us through the National Climate Data Center. But that's hardly the general public audience you were asking about. And Sherry, take everybody into orbit would be a fabulous thing, but I'm not naive that everyone might feel that similar emotional blush. But you can even just look at the population of astronauts. They may all have that rush of emotion and a sort of breakthrough ahas when they look at the Earth. But you bring people back down to society, to culture, to context, and it takes action, it takes form, it translates out into many varied different ways. So at the end of the day, if I could take everyone to orbit and then bring them back home and put them back into community conversations with their community and their place and the experiences, the events, the trends that their community is facing. We are seeing, I find, very encouraging signs on the ground in a lot of places. South Florida, 3 large counties, very different politics, very different economics, and very different demographics across the 3 counties. But they're seeing in common saltwater intrusion into their groundwater, increased nuisance flooding, not even knowing the science data, their experience is telling them the life we've built here, and these are elected officials responsible for their communities, the life we've built here, the infrastructure we've built here, the businesses and families we've built here can't go on the way we've been going on. What are we going to do together to try to move on to a new path? Those give me great heart.
So we are pretty much out of time. I want to just know, anyone who has a question that's a burning question, revkin@nytimes.com. I know these people. I can get answers and I can post them on .earth as a public, sustaining this conversation. There are a couple quick things I wanted to note in answer to these questions. One is, on the infrastructure question, there are some scientists in Alabama, climate scientists, who said the inverse thing is to not move the water around, but move the agriculture around. For example, they said California is the worst place, basically, to have our vegetable basket. It's so much of what's out there is subsidized water use. Come to the southeast, they're saying. So finding ways to sort of eliminate these hidden subsidies that have sustained water irrational use might be something. The Pope, on your point, the Pope made a wonderful comment hidden deep in the encyclical about this social and media environment we're now immersed in, and about how much of it is isolating and polarizing when in fact it could be connecting and a problem-solving tool. And I was really excited to see that, because that's what I try to do at Pace University and others I know. So finding ways to engage astronauts with the public, and having that, as you were saying yesterday, it was so important, there has to be a sort of face-to-face part of this, but it has to be integrated with the reality that we're in a social and digital media environment now too. Finding ways to have a hybrid experience, having people share their own stories about climate changes they perceive, finding ways to integrate those two things, the virtual and the real, is really important. Sharing success stories on water conservation as well. And then on what the public feels about global warming, I've tracked this for, decades. And my metaphor, and it could feel like it's frustrating, is that public attitudes on global warming are like water sloshing in a shallow pan. So you're a waiter, you're carrying like a tureen of soup. And over the decades, there's been a lot of sloshing in that pan, but the depth of concerns about climate change has not changed, going back decades, literally decades. So don't count on some epiphany on global warming, getting back to your question, being the thing that magically propels us forward. There are huge opportunities to build smart approaches to our relationship with the climate system, from the local level to the agency level, that we can pursue right now. And sustaining the relationship between academia and agencies is really important too. So I think we have to leave it at that because we're out of time. But again, revkin@nytimes.com for further discussion, and thank you very much.